That's pretty funny. Okay, guys, let's go. I got this thing recording, so let's go ahead and get started. So our lesson today, I have it on the board. I'll rewrite it right here. This is going to be for section 2.5, and what we're trying to do is we're going to graph multiple equations, or multiple variable equations. And we got a second little mini lesson on inequalities, and a third little lesson on proportional relationships. So we got a lot of things going on, right? We got this, multiple variable equations. Oh my gosh, we got inequalities. We got proportional relationships. We got a lot of things happening. So we got a lot to get through. So bear with me. Ask questions as you need to. I'm sure the people who are watching the video may have similar questions. Graphing multiple variable equations is probably the best way to do it is just to think about what we have been doing. You know, when I say multiple variable, what I mean is that it has, like when I say multiple variable, I'm saying that there's a relationship. There's a relationship between x and y, right? And so, like, the common way that I give you guys these equations is I'll say, you know, there's slope-intercept form, which is y equals mx plus b. So we're very used to seeing, like, real-world examples. You know, for example, we're very used to seeing examples that look like y equals, 1/2 x minus 4, or something like that, okay? That is one way that we do it. Another way we do it is we have standard form. And this is going to be ax plus by equals c. So this might look something like, 3x plus 4y equals, 24. Something like that, okay? So using these, we have to figure out how we're going to graph them. And so when I look at something in slope-intercept form, my steps aren't too bad. I mean, step 1 is find the y-intercept. Find the y-intercept. So for my example here, y equals 1/2 x minus 4. What is my y-intercept? Bueller? What's my y-intercept for my example here? Ryan? -4, absolutely. So in this case, it's -4. And so what I would do is I would have a graph. I would find -4 on that graph on my y. 1, 2, 3, 4. And I would make a dot. So this is my step 1. Step 1. My step 2 would be to find the slope. So for my example here, y equals 1/2 x minus 4. What's my slope? Colin?
Me?
Yes?
For slope-intercept?
For this one right here.
Okay, that's 1/2.
1/2, absolutely. So in this case, it's 1/2. And so that's telling me to go up 1 over 2. Up 1 over 2, right? So that's step 2. And from that, I have my line, and I am good. This is all mostly review. This is just slope-intercept form. But I want to compare it to what I'm asking you guys to do when we do standard form. I feel like I need to be a little bit more clear on this. So when I'm doing something in standard form, I have, for example, 3x plus 4y equals 24. One of the ways that we've done it before is we have solved for, we've treated it like a literal equation, gotten it to y equals mx plus b form. But we don't have to do that anymore. We now know that we can do it by finding the intercept. So step 1 is find the y-intercept. And how do we find the y-intercept of a standard form equation? Yes? Yeah, you plug in a 0. And if we're finding the y-intercept, we're going to plug in a 0 for x. So here's the thing. If I had 3 times 0, this whole term just disappears. It becomes 0. So that becomes 4y equals 24. So then I divide by 4, y equals 6. So I found my intercept. So I'm going to do another little graph. I'll do this one. Actually, I'll do it over here. Can you see that? So in this case, y equals 6, 1, 2, 3, 4, 5, 6. It's all the way up here. And there's my intercept. Okay. Step 2 is find x-intercept. And so if I plugged in 0 for x to find my y, I'm going to plug in 0 for y to find my x. That leaves me with 3x equals 24. Divide by 3, x equals 8. So then I go over 1, 2, 3, 4, 5, 6, 7, 8. It's all the way over here. I have 2 points. 2 points is all I need for a line.
For x and y, you're throwing in zeros?
I'm putting in zeros.
Okay.
All right, that's how we do standard form. Right, because this 3x becomes 0 plus 4y. And then this, the 4y becomes 0. And that, as they say, is that. So that's how we do it in both slope-intercept form and standard form. Do you guys want me to leave this up here for a second? Thumbs up if you're still copying it down. Okay, cool. I'll leave this up for just a second more. This is all mostly review. This should be in your notes already. This is just a chance to look at them one more time with fresh eyes. That's our multiple variable equations. We have 2 forms of multivariable equations. One is slope-intercept form, one is standard form. And these are the 2 steps that we use to graph each of them. We either find the y-intercept and then use the slope, or we plug in zeros to find our intercepts. How many of you guys prefer slope-intercept form? You find that one to be easier. How many of you guys prefer standard form? You find this one to be easier. How many of you guys are ambidextrous with the forms, meaning you can do either just fine? I could give you anything, and you're like, Victor, I got it. Sweet, there's a lot of thumbs up on that one. That's what I like to see. So the only thing that gets a little hairy is this next section where suddenly we're not doing equations, we're doing inequalities. So I'm going to rewrite our slope-intercept. If I have y is less than or equal to 1/2 x minus 4. Oh, sorry guys. Let me move it down. Thank you. Y is less than or equal to 1/2 x minus 4. So this is the same numbers as the example we just did. The only difference is suddenly we have a less than or equals to sign. We have an inequality symbol this time around. So I'm going to graph it the same way I graphed it before.
And that means you have to shade?
That means we're going to have to shade. That's right. And so I want to just go over one more time on video how we do that. So the first thing, step 1 is still find the b, -4, 1, 2, 3, 4. Step 2 is find the slope and do that, up 1 over 2, up 1 over 2, up 1 over 2. And again, I always recommend that whenever you're doing this on a piece of graph paper, you try to do each and every slope step. That way you don't accidentally miss one or it doesn't get sloppy. And we do something like this. Boom, 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 boom. And finally, this is the part that I think we're struggling with, is we have to look at this here where it says y is less than or equal to y. Now, there's two ways that I like to think about it to figure out which side do I shade. Okay? What side do I shade? There's method one. Method one is view the y-axis as a number line. So what do I mean by that? View the y-axis as a number line. Well, this is our y-axis, right? And let's imagine instead of it being this two-dimensional xy coordinate, what if instead I just viewed that line as a number line, right? Here it is, 1, 2, 3, 4, this is 0, -1, -2, -3, okay? And so when I look at my equation, y is less than or equal to, well, y is less than or equal to, let's say this point right here. If this were just a number line, and I asked you to shade it, and I said, okay, where is y less than or equal to this point? We would say, oh, it's less than or equal to going that way. Does that make sense? If we're ignoring everything else, we're just viewing this point and this line. And I would say, okay, y is less than or equal to going that way. That tells me to shade this whole side of the line. That's one way I like to think about it.
You shade the bottom part?
Yeah, we would then shade below the green line. The other way I like to do it is I decide, and this is more of a visual way, what side is above the line, and then what side is below the line. Okay? When I look at this green line, if I imagine this green line was cutting everything in half, I would say that this side is above the line, and I would say that this side is below the line. And then I look at my inequality. It's less than or equal to, less means below, right? So that would tell me to shade this side of the line, the below the line. And likewise, greater than or equal to or greater than would mean above the line. Okay? That's one way of thinking about it. Finally, if neither of these ways work for you, if looking at these you're like, Victor, like above the line, below the line, I don't see it, number line, totally don't see it. The third way to do it is a test point. My favorite test point is 0, 0. This is my fave. And what we do here is we take our test point and we plug it into our original inequality. So I have 0 is less than or equal to half of 0 minus 4. Half of 0 is 0, so 0 is less than or equal to -4. Is that true? No. Not true. And so that tells me if it's not true, I do not shade. If not, don't shade that side. If it is, shade it. So if I had picked a point like right here, this is the point, what is that point? 2, -4. So I'm going to try that in. -4 is less than or equal to half of 2 minus 4. -4 is less than or equal to 1 minus 4. -4 is less than or equal to -3. That's true. That tells me that this point's good. shade that side. Okay, so now you guys have 3 different methods of figuring out what side to shade. How many of you guys like naturally do number 1? Like you view it as an underline. Is that a couple of us? How many of you guys do number 2? You view above and below. How many of you guys need to use the test point? 3. Okay, cool. Different ways of doing it. You know, it's like the old analogy. It doesn't matter how you get there. You can walk, bike, take your car, whatever works for you. Yeah.
You should just think about it this way. Since it's going less than, go below the line.
Yeah. Yeah. That's kind of how that's kind of what I'm saying in 2, except I said it in like mathy language. But yeah, if it's less than, it's below the line. If it's greater than, it's above. Absolutely. Cool. We feeling good on this?
Feel groovy.
Got one more thing I wanna roll with you. Okay. So this is our last section. This is going to be on proportional relationships. And a proportional relationship is 2 things that happen together. Yeah, let me slow it down. Thank you. Sorry. 2 things that happen together. For example, 2 things that always happen together are, well, one thing, the more I work, two, the more I get paid. Right? If I only worked 1 hour, they'd only pay me for 1 hour. If I work 8 hours, they'll pay me for 8 hours. Right? It's a proportional relationship. As one goes up, the other goes up. Okay? So let's imagine, for example, it was my first job. I was a sandwich delivery boy. I made $10 an hour. So Victor made $10 an hour. And so what I'm going to ask you guys to do is with this is come up with a couple things. This is our scenario. I'm going to ask you guys to come up with 1, an equation, 2, a graph, and 3, a table. Okay? What sounds easier? What do you guys want me to do first? Hold up. 1 if you want me to do the equation, 2 if you want me to do the graph, or 3 you want me to do the table. What seems easier? I'm going to stand up so I can see everybody. I see 2s and 3s. A couple ambitious people are throwing up 1s. I'm going to do 3. I'll do a table first. And actually, I recommend doing a table first. A table is one of the easier ways of understanding it. Bless you.
Thank you.
So I'm going to do a table. Table's going to look like this. Okay, hold on one second. Let me finish drawing it, and I'll bring it down. Thank you. All right. Table's going to look like this. This is going to be the number of hours I work. This is going to be how much money I make. So if I work 0 hours, how much am I getting paid? 0. If I work 1 hour, how much am I getting paid? 2 hours? 3 hours? 4 hours? And we can go on and on and on forever if we wanted. Okay? Awesome. Table is done. Now I'm going to make a graph. Okay, let's view the graph like this. You know? Okay, so we'll say that this is going to be our time, and usually x is time. So we'll say this is time in hours. And this is going to be money in $10 increments. So this is going to be 10, 20, 30, 40. So at 1 hour, I made 10. At 2 hours, I made 20. At 3 hours, I made 30. And at 4 hours, I made 40. And so this is what my graph will look like. Okay. I had to scale my graph right here so that it would fit. Otherwise, it's all the way up here, and then it grows really, really fast. So be careful when you're looking at your scale of things. Finally, I'm going to do my equation. And let me look at this, right? Let me look at this. So, what's my y-intercept here? Well, it crosses right here at 0. So if I had y equals mx plus b, I see that it crosses at 0 here. So that'd be plus 0. And then what's my slope? Well, I go up 10 over 1. So my m is 10. So y equals 10x plus 0, or simply y equals 10x. Now, in previous examples, I didn't necessarily use x and y, but this will work for being able to describe this relationship.
Wait, can you,
Slide it up just a little bit there. Sorry, guys. Okay? So just from this little bit of information, I was able to construct 3 different ways of representing what was going on. Does that make sense? And so that's what I'm going to be asking you guys to do when we're doing proportional relationships. There's 4 problems on the homework about this. And in each time, it's either going to give you one of these things. It's either going to give you the scenario, the equation, the graph, or the table. And from that, you have to construct the other 3. Any questions on all of this? You guys ready to do it? Tired of hearing my voice? No problemo. I'll go ahead and stop this thing, give you guys the rest of the time to work.